John's solution to an equation is shown below, and we're given x squared plus 5x plus 6 equals 0, and 3 steps there. And the question asks, which property of real numbers did John use for step 2? So in step 2, we're setting the factors above equal to 0, because we've learned if you multiply two numbers and you get 0, then one of those numbers has to be 0. And the name for that property is option B, the zero product property of multiplication. It's not super important to know that name. You could have guessed your way to that answer. But let's take a look at these other options to see what they're talking about. Option A says the multiplication property of equality. So for example, if we have an equation, 1/2 x equals 4, this property in option A says that we can multiply both sides by the same number. That is the multiplication property of equality. This is something you already know, but you might not have known the technical term for it. And for this problem, step 2 is definitely not using that. Moving on to C, the commutative property of multiplication. So when you see commutative, that has to do with order. So the order property of multiplication. That means, for example, 5 times 3 is the same as 3 times 5. You can multiply numbers in any order. Again, we don't see that in step 2. And finally, D, the distributive property of multiplication over addition. So that means we have the distributive property, and in parentheses we have some addition. So we would multiply the 2 by each piece on the inside. If they said over subtraction, that means we have a minus sign on the inside. Again, this is a property you already know. They're just giving it a technical name for it. And as with A and C, we're not using that in this problem. The property we're using has to do with zeros, so guessing B would have been a good guess. If x squared is added to x, the sum is 42. Which of the following could be the value of x? Let's translate this first sentence into math. So x squared is added to x, so we have our plus sign, and the sum is 42. So this is equal to 42. And now we just need to solve for x. With quadratic equations, we need to get everything to one side. So we have x squared plus x minus 42 equals 0. On the left side, we have a quadratic expression, which we can factor into x plus smiley face times x plus heart. At this point, you might be able to factor this without using a table. We've learned that smiley face and heart are two numbers that multiply to negative 42 and add up to 1, which is that coefficient on x. You might already know the answer. If you don't, you could write down which numbers multiply to 42. For example, 2 and 21, 3 and 14, 6 and 7. And you can ask yourself, where can I place a negative so that the pair of numbers adds up to 1? Well, you can place a negative on 6. So negative 6 times 7 would give us negative 42, and negative 6 plus 7 equals 1. So we found our smiley face and heart. So now we can rewrite our line from above as x minus 6 times x plus 7 equals 0. Now using that zero product property that we learned in the previous problem, we're multiplying two numbers and we get 0. So either the first one is equal to 0 or the second one is equal to 0. On the left side, we can add 6 to both sides and we'll get x equals 6. And on the right, subtracting 7 from both sides gives us x equals negative 7. So x could be 6 or negative 7. And the question asks, which of the following could be the value of x? The only one that works is option A. What are the solutions for the quadratic equation x squared plus 6x equals 16? So this is similar to the previous problem. Let's rewrite our quadratic equation. Let's subtract 16, so we get all our numbers to the left side. So we'll have x squared plus 6x minus 16 equals 0. Now our left side we can factor into x plus smiley face times x plus heart. So let's see which numbers multiply to 16. You could have 1 and 16, 2 and 8, 4 and 4, and we need to place a negative somewhere so that the numbers add up to 6, and we can place a negative on 2. So negative 2 times 8 equals negative 16, and negative 2 plus 8 gives us 6. So we'll have negative 2 and 8. So we'll rewrite our equation as x minus 2 times x plus 8 equals 0. And using our zero product property, we can set each of our numbers here equal to 0. Or a quicker way, you could get straight to the answer by asking which number can I place in for x to make that factor 0. So if I placed a 2 here, we get 2 minus 2, which is 0, and then 0 multiplied by something equals 0. So that would be a true equation. Similarly, if x is negative 8, then our second factor is 0. So if x equals 2, or x equals negative 8, we have a true equation. So doing this just skips that middle step of setting each of the factors equal to 0. If you feel more comfortable writing that middle step, feel free to keep doing it. But our answer here is x equals 2 or x equals negative 8. And looking at our options, that's option C. What are the solutions for the quadratic equation x squared minus 8x equals 9? We'll subtract 9 from both sides. So we'll get x squared minus 8x minus 9 equals 0. Now we can factor the left side, and you might have done enough practice to go straight to the answer. So our smiley face and heart are 1 and negative 9. They multiply to get negative 9, and they add up to get negative 8. And if we set each of our numbers here equal to 0, we'd get x equals negative 1 or x equals 9. And looking at our options, that's option D. Four steps to derive the quadratic formula are shown below, and the question asks, what is the correct order for these steps? So this isn't a great problem for a test. If you check the bonus playlist, I show how to derive the quadratic formula, and each of these four steps shows up in there. The answer is going to be A. I encourage you to check out that video if you'd like to understand why, but it's not a great problem for a test, so we'll skip it here. Which is one of the solutions to the equation 2x squared minus x minus 4 equals 0. So we have a quadratic equation, and it's set equal to 0. So our next steps would be to either factor or use the quadratic formula. And if you see square roots in the answer choices, that's a hint that you're going to need the quadratic formula because it has a big square root in it. So let's rewrite the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. And the a, b, and c refer to the general form of the quadratic equation, which looks like y equals x squared plus bx plus c. So if we rewrite our quadratic equation in that form, we would get y equals 2x squared plus negative 1 times x plus negative 4. So writing it like that matches our general form with these plus signs. So we know that a is 2, b is negative 1, and c is negative 4. And now we can plug those values into the quadratic formula. So we have x equals negative of -1 plus or minus the square root of -1 squared minus 4 times 2 times -4 all over 2 times 2. Simplifying this, negative of a negative number is a positive, so we get positive 1. Inside the square root, we get -1 squared, which is 1. We leave our minus sign, and then we multiply our three numbers. 4 times 2 is 8, times -4 is -32. And on bottom, 2 times 2 is 4. So we just have the square root to simplify. 1 minus -32 is the same as 1 plus 32. And 1 plus 32 is 33. So our x is equal to 1 plus or minus the square root of 33 over 4. And we can split that into two solutions. So x could be 1 plus the square root of 33 over 4, or x could be 1 minus the square root of 33 over 4. Again, when we're solving a quadratic equation, we set it equal to 0, which means when we're solving for x, we're finding the roots of a parabola. So our solutions down below are both roots of a parabola. And the question's asking, which is one of the solutions to this equation? It could have also said, which is one of the roots for this equation. And the only option that matches one of our roots is option C. Which statement best explains why there is no real solution to the quadratic equation 2x squared plus x plus 7 equals 0? Our two ways for solving a quadratic equation are factoring and the quadratic formula. They're telling us that our equation here has no real solution. That means we won't be able to factor it, because if we could factor it, then we'd have a solution. Now let's say we try to solve this using the quadratic formula. Let's rewrite it here. And using our equation here, we know that a is 2, b is 1, and c is 7. So let's try plugging those numbers in. So we'll have -1 plus or minus 1 squared minus 4 times 2 times 7 all over 2 times 2. So looking at our square root, you can only have the square root of a positive number. So if we get a negative number in there, that's our quadratic formula telling us there's no solution. There's no roots. So let's take a look at that part in the square root. So 1 squared is 1, and then 4 times 2 is 8, times 7 is 56. So 1 minus 56 gives us -55. So under that square root, we're going to get -55. We cannot take the square root of -55. So we would say there is no solution. There are no roots. Now our quadratic formula represents a parabola, so how would that look on a graph? So the parabola we have here would look something like this. This parabola is above the x-axis, so there are no roots. So the part under the square root, our b squared minus 4ac, there's a special name for it. It's called the discriminant. And it's useful for seeing how many roots we have. As we've seen, if it's negative, there are no roots. So our parabola is going to be above or below the x-axis. It's not going to cross. If our discriminant is positive, then our square root likes that. You can take the square root of a positive number. In that case, we don't have any issue, and so we're going to get 2 roots. If our discriminant is 0, then the square root of 0 is 0, So our plus or minus piece here just disappears. And so we'd have x is equal to negative b over 2a. And since we removed this plus or minus, we don't have two roots, we just have one. So what would that look like on the graph? That would mean our parabola touches the x-axis at exactly 1 point. So the discriminant is useful for seeing how many roots we have, but it's not a new concept, it's just part of the quadratic formula. And looking at our options, they assume your mind goes straight to the discriminant. And the reason why there is no solution is that the value of that discriminant is negative. So option C would be the answer. So if our discriminant were positive, we'd have two roots. If it were 0, that's one root. If it were negative, we have no roots. And option D mentions a perfect square, which is just random. It doesn't matter if the discriminant is a perfect square or not. So that is an easy one to cross out. What is the solution set of the quadratic equation 8x squared plus 2x plus 1 equals 0? So we could try to factor this, but since we see square roots in the options, let's use the quadratic formula. And in this case, our a is 8, b is 2, and c is 1. Plugging that in, we get negative 2 plus or minus the square root of 2 squared minus 4 times 8 times 1 all over 2 times 8. Under the square root, we get 2 squared, which is 4, minus 4 times 8 is 32, times 1 is still 32. And on bottom, we get 2 times 8, which is 16. And 4 minus 32 is negative 28. So we have a negative under the square root. Our discriminant is negative. And what does that mean? No solution. So our quadratic equation is going to form a parabola that does not cross the x-axis. There are no roots. And looking at our options, the answer is option D.